So at the end of the last tutorial we had set up all our layers and created some animations. Using each one of those different layers. We then thought, looking at our character, that we could perhaps turn this into a state tree. And then, seeing that we've got some quite good animations, we could also turn that into a state tree enemy AI, where we could have some NPCs running these different layers with a state tree AI component. So today we're going to start off trying to put that into action. Now I've done some previous videos on state trees which are worth looking at. Also, if you haven't seen part 1 and 2 of how we set up all of these different layers, locomotion layers, crouch layer, and so forth, it's worth watching. The third thing is you'll also need to know about gameplay tags, because that's the best way of driving state tree changes. So there's also a video on that to look at. So in terms of setting up a state tree for our player character, there are a number of things we need to do. One, we need to set up some input actions to activate each of these functions. Secondly, we need to set up some gameplay tags to use in our state tree. And 3, we need to set up a state tree component to use. So if we do the first one, so to begin with, well, let's think about this. So we've got either standing or crouching, and either aiming or not aiming. So we could just have 2 different input actions, one that alternates between stand and crouch and stand, and the other that goes from aim to not aiming and not aiming to aiming. So if we go to our content drawer, go to our third person, go to input. This is where the default input mapping context is. We'll create a new input mapping context just for our character. So input mapping context, IMC, say combat. Here are where the default input actions are, so jump, look, move. We can maybe just add our input actions here. So input action, IA, crouch, stand, and we can duplicate that and call it IA, aim, no aim. Now if we go back to our input mapping context, IMC combat, we can add those input actions here. So the first one will be IA crouch stand. We'll maybe use C for that. So click, press C. We don't need to change anything here. It's just a default press action. We'll do another mapping. This will be our aim, no aim. And maybe we'll just use X for the time being. So that sets up our input mapping context. What we need to do is add this context to our player controller. We did create a weapon component, if I remember, that's correct, which we added to our player. So we can maybe try to do that here in a function. So a function will be add combat mapping context. We need our get player controller. get enhanced input local player subsystem, and then we can just say add mapping context, and our mapping context is our IMC combat. So that should add that mapping context. Here we can just call that function. We maybe don't need this. We can then hook into those input actions in the actual component itself, I think. So IA crouch stand and IA aim no aim. So we probably want it on started. Let's make sure that this does work. Print crouch. If we just play the game, and if I press C, yep, we get a crouch in the top left. So we are getting the input in our actor component. So the next thing we want to do is create some gameplay tags to determine what state we are in. So again, if we go back to our content browser, maybe to our tutorials, we can maybe just create a folder called data, because we'll do that via a data table. So we'll right click, go to miscellaneous, look for data table, and we'll look for gameplay tag table row. Click on that. OK. This is our DT. Just call this data table states to begin with. Open that. So if we think about it, we're going to be in 4 different possibilities. We are either standing, not aiming, standing, aiming, crouching, not aiming, crouching, aiming. So we can create some gameplay tags to take advantage of that. So our first one will say state.standing.no aiming. We can duplicate that. This will be state.standing.aiming. Duplicate that. This will be state.crouching.no aiming. And the last one will be state.crouching.aiming. So those are our states. Now to add that to our project, we go to the settings, project settings, look for gameplay tags, gameplay tag table list. So we can just add our table that we created, DT states, and they should be automatically added. Close that, go back to our component, compile that. So when we press the crouch stand, we'll assume that our default state is standing, no aiming. So we should probably keep a reference to what the default state is. So if we create a variable, this will be our gameplay state tag. It will be of type gameplay tag. We'll compile and we'll say our default tag is state standing, no aiming. So when we press the start, we're going to flip-flop between crouching and standing. So flip-flop. Or instead of flip-flopping, maybe we can use a switch. So gameplay state tag, we can switch depending on what our current tag is. So let's put some of these in. We can go here. So if we are standing dot aiming, we'll then go and become crouching dot aiming. So we'll say gameplay state tag set to crouching aiming. If we are standing and no aiming, so standing dot no aiming, this will become crouching dot no aiming. So it'll just become the opposite. So we need two more possibilities. If we are crouching aiming, then this will become standing aiming. And if we are crouching no aiming, then this will become state standing no aiming. So it will become one of these each time we press it. So if we're standing and aiming, we go to crouching and aiming. If we're standing no aiming, we crouch no aim. If we're crouching aiming, we stand and aim. And if we're crouching no aiming, we stand no aiming. So I think that makes logical sense. So that's crouch stand. So in the aiming no aiming, it's essentially we do this again, but the difference is if we are standing aiming, we would then go to standing no aiming. So the standing or the crouching always remains. So we could just take all of these, Control V. So if we're state.standing aiming, we'd go to state.standing no aiming. If we're standing no aiming, we go to standing aiming. If we're crouching aiming, we go to crouching no aiming. And if we're crouching no aiming, we now go to crouching aiming. So that should hopefully cover the logic of switching from standing to crouch and then from aiming to not aiming. So we could maybe just test to make sure this is all working. So let's just do a event tick. Let's print and we'll print what our current gameplay state tag is. Should be able to say to text, or we can split this, I think. Can we break that? We can get tag name, or get debug string from gameplay tag. Let's try this. And we'll just put that at 0 so it remains on the screen. Let's have a look. So we're state.standing no aiming. If we press C, we go to crouching aiming. Press C again, we go to standing aiming. I press X, I go to no aiming, standing no aiming. Back to standing aiming. I'm crouching, I press X, I go from aiming to no aiming. Of course, we haven't hooked up the animations, but the keys are working when I press them. So we've done the input actions and we've done the gameplay tags. The next step will be to create a state tree. We'll need to make sure that our state tree is set up in the plugins. So go to plugins, search for state tree, and we'll need to take state tree, gameplay state tree. I think it's just those two. We just look for gameplay. So gameplay tags are by default activated anyway. So the main thing is you need to make sure that your state tree component, these two, gameplay state tree and state tree, have been ticked, and then you'll need to restart your editor. So once you've restarted your engine, after activating these two plugins, we can maybe add our first state tree. So if we go to our character that we're using, we can add a state tree component from here. So add state tree. Now there's two options, state tree AI and state tree. We'll add a state tree in this character because there is no AI control. Now if we decide to make an enemy AI driven by state tree, and we can do that if there's enough interest, so do subscribe, like or comment to show that. We'll then use this on an AI controller. But in our case we'll go for state tree. So compile that, and across here now we need to create a state tree to run our logic. State trees are very flexible, so you can add a state tree to almost any actor, and as long as it has definable states, you can control those transitions between the states. So you could have like a light which is on, off, flashing, dot red, dot blue, and so on. So there's many uses for it. If we go back here, go back to our tutorial, and we create a folder, we'll call that state tree, and we'll create our first state tree. So if we go down to artificial intelligence, we now have access to state tree, and we'll choose a state tree component. We'll call that state tree combat. Combat animation. Combat animation layer interface, ALI. So now we can open that. Now I've made some previous videos on state trees, and what we'll try to do is we'll make this as simple as possible. So on the left we've got the schema, so this is attached to, will be attached to a state tree component, which will then give us access to a context actor. You can set parameters, you can create global tasks, but what we'll do is we'll just keep this with a simple state tree. So we'll start from root, we'll add probably 4 states for each of our 4 animation layers. So that will be our first state, and that will be standing, no aiming. Another one, that will be standing, aiming. Another state, crouching, no aiming. And you can either just add state here, or you can right click and say add state, child state. And this will be crouching, aiming. So these are our 4 states, and we'll have transition rules to decide how they can go between them. When you go across to any one, you can add tasks. So each state will have a task or multiple tasks that it will run, and then it will have transitions to determine how it can move from one state to another. You can also set enter conditions. So you could have like booleans or gameplay tags which would determine whether a transition can enter this state or not. Basically, when we start the tree, the first state it will go to is the standing, no aiming. So directly it will go there unless there is something, a condition that prevents it. So how do we create state tree tasks? Well, unlike behavior trees, there's no easy way to create it at present in the state tree itself. So we'll need to go back to our folder. We'll just create a new folder, call them tasks. And to create a state tree task, you right click, go to Blueprint, All Classes, and if you search for state tree, what we're looking for is state tree task blueprint base. So every state that you create in that state tree, this will be our base. So we'll click on that, we'll select. Instead of having to do that each time, we'll just call this our base task. And then from there we can create child blueprints. It also means that we can set some details in the base task, because we will want to know certain things about our character in order to drive the animation changes. So if we go back, open our base task, we'll probably want to have access to this actor context. So we can go there, say variable, we can call that actor. The interesting thing is you can change the type, I think, or can you not? Schema, yeah. So down on schema you can change the context actor. Well, ours is going to be a character, we know that. So let's just do character. Compile. So now this context actor will be of type character. So in our base task we can change the type here to character. Object reference. We'll expose it so that it shows up on the state tree, and that's important. So we'll do that. And then from here we can now create a task that changes the animation layer. So if we right click, say create child blueprint class, we'll call that state tree task change animation layer. It should probably be link animation layer, so it's consistent with the actual command. So we do that. Now when we open this, we'll have access to our actor. And in essence, in all state trees, you have overridable functions. So when the state tree enters the task, it will call enter state. It will then allow you to override the tick. At the end of the state, when you complete it, you'll get state completed. And when it actually leaves this state and moves on to another state, it will call exit state. So using these override functions, we can control our animation tree and add extra logic or functionality, particularly in the future if we create an enemy AI based on a state tree. So if we go back to our state tree, and let's just illustrate what we're going to do. So this is our standing no aiming. We'll right click and we'll say add a child state. This will be the stand no aim link layer. We can add sort of tasks to the main one, or we can add it as a child. We'll just do it as a child here. So we go to the task, click, and we've got access to our state tree link animation layer. We right click that. Now this is an important part. So we set up an actor reference, which is of type character. We can just click here. We can bind it. So if you go to this right side, we can bind it to the actor, which is our actor class. So now the two are bound. But there is another way that you can do this to make life easier. So if you remove the binding, we go back to our base task, and on the actor, if we change the category to context, now we compile, we go back to our state tree, we see that it's automatically bound to the context actor. So anything which is a context here, so it could be a context actor, or if you do a state tree AI component, there will be an AI controller. If you put the category belongs to as context, the state tree will automatically bind it, so you don't need to keep doing that every time. So we enter this state, it goes from there to here and directly to here, and then it runs the first task. So we need to tell it what layer to bind based on this. Let's go back here. So if we go back to our tutorial character, this is how we were doing it originally. We were getting the mesh saying link anim class layers, and we were using this anim instance class reference. So this is a type of variable that we need to set here. So we type in variable link anim layer class. I think that was called anim instance class reference. Well, we can work that out. So basically when we enter the state, we'll override the enter state. What I sometimes like to do is to do some sort of housekeeping in the base task. So just in case we do that, we can override the enter state here. We won't do anything at the moment, but then in any of our child classes, we can just call the parent just in case we do something there. Now we know that our actor, it might be easy if we change that to character. So go back to base. Character reference. Hopefully that should update everywhere. Let's have a look. Yes. go back to our link animation layer task. We'll get our character reference, which has been automatically set. We can just make sure that that's valid. Then we can get the mesh. And like we did originally, we just have to say link anim class layers. Okay, and we can put this in here, I think. Yes. So that should compile and save OK. So we'll want to set this layer class in the state tree, so we will expose it here. And if we go back to our state tree, we should now have access to this. Now if we remember, we created 4 layers. So there's a standing layer where there's no aiming, there's a crouching layer where there's no aiming, there's a standing layer with a gun being aimed, and a crouching layer with a gun being aimed. So those were our 4 layers. So back to our tree, this is stand no aim, so that our class here will be just the standing layer. So that's the one that we will switch to there. Standing aiming, so we can just add another state. We can call that stand aiming link layer task. And here we'll add another task. Again the same, so the link animation layer, that's automatically linked, and we'll link this to standing aiming. Here we'll add another state, our crouch no aim layer, another task, link animation. The class we'll do is just the crouch layer, so this is no aiming. And here we'll do one more, so right click, add a child state. This will be our crouch aiming layer. Another task, and this will be our crouch aiming layer. So we've got each one of these states will activate a different layer. So the question is, how do they go from one state to the other? Because once it enters a state, it will stay in that state unless you call finish task, and you can tell it whether it succeeded or failed. We actually don't want it to come out of the state unless it receives an event to change states. So we don't want this to call here at the moment. So the way that we will change things is, essentially on any of these states you can put a transition, and you can say when you receive on an event will send a gameplay tag, so this could get any of those events that we sent to go from standing to aiming, or from standing to crouching, and so on. Once it's got that, we can then pick which state it goes to next. So if it got the standing aiming gameplay tag, we would say go to this state. We can give it a priority, so is this medium, high, or critical? We can delay the transition by a second or two. We can also add conditions, so perhaps it can only go from one state to another if a certain condition is met, or it ignores the event. But instead of putting on each one of these an event. You can just put the event on the main root, which would apply to every state down below. And that would be the best thing to do. So we'll remove that there. We'll go to the root and we'll say we'll start adding our transitions. So on event, so if it gets the, let's do standing first, standing, no aiming, it goes to standing, no aiming state. We'll do another transition, another event. If it gets the standing aiming gameplay tag, it will go to the standing aiming we could send it directly to the layer, but if it comes here it will go down automatically. So standing aiming, standing no aiming, another transition. On event, crouch no aiming, it transitions to crouching no aiming. And one more. On event, crouching aiming, it transitions to crouching aiming. So compile, save. So that should hopefully deal with the logic. Now it's all about how do we send these events to our state tree to trigger the transitions. Also, I think if it was to receive multiple transitions, it will sort of assess them in this order unless something has a higher priority. So we've hooked up our input actions in our actor component here, if you remember correctly from our last video, where we can go from crouch to stand or from aiming to no aiming, and we set a gameplay tag. So it's better that we trigger the events on our state tree from here rather than from our character. So we can just remove some of this because we're not going to be using that. So let's get rid of this debug stuff. In order to be able to send a state tree event, the first thing we'll need is a reference to our state tree. So we've done this set references where we get the character. What we can actually do is just use a get component by class. So there's only one state tree at the moment, so we can do that. We can choose state tree component as our component, and we can promote that to a variable. So state tree reference. So now as long as our character has a state tree, we will get access to the state tree. Then back here, on each one of these, once we've done, pressed it, start, set the gameplay state tag, we can then take advantage of the completed. So if we create another function, and we just say send state tree event gameplay tag to make it clear. From here we can get our state tree reference. Let's make sure it's still a valid state tree. And all you have to now do is say send state tree event. This, if you right click and split, you can now send an event tag. Our event tag will be the gameplay state tag which we set earlier. I'm not quite sure how you access this information in blueprints anyway, so we can leave it or just say event origin AC weapon. So we go back here on completed, we can just call send state tree event gameplay tag. And same here, when we've taken our finger off the button, we can say send state tree event tag. So that should send an event to our state tree, and as we put all of the transitions in the root, regardless of which state it is in, it will receive this event and then trigger a change, a transition to the next state. That should then enter the new state tree task and change the animation layer on the character the state tree is attached to. So this logic is here. We go back to our tutorial character. This is our state tree. Now we have to set the actual state tree that we're going to use here. Combat ALI. Unfortunately in blueprints you can't change or set the state tree in blueprints, so get set state tree reference, no. So you can't set the state tree or change it in blueprints, which is a limitation. So you have to just set it directly here. So that's set, it will start automatically. Now if you notice, we also did some of this at the end of it. So once it had done the played the animations, standing or crouching or reversing, we'd then do the opposite. We'd uncrouch, crouch, uncrouch, crouch. So we need to somehow do this in our task as well. So we should perhaps try to put this into the task that we are running. And the way it seems to work is that if we are standing, we make sure that we are uncrouching, and if it involves any crouching, we set crouch on the character. So we need to replicate this with basically just with a delay like that. So if we go here, after we've linked the layer, we can do a delay. That we calculated that the animation length was about 0.6 seconds. Now how do we decide whether we need to crouch or uncrouch? Well, we could somehow use the layer here, or we can give ourselves, maybe we should keep a reference to what the gameplay state tag is. So gameplay state tag for this task, and expose it, compile, go to our combat tree, so here. So this one is, no, so we need to set it as a gameplay tag. So this is standing, this is state, standing, no aiming. This is state, standing, aiming. This is state, crouching, no aiming. This is crouching, aiming. This is crouching, aiming. So here we can take advantage of that. We can get our gameplay state tag. We can just say, I think there's a contains. No, there's no contain, so we can do a switch again. and we could just copy the one that we did previously. So it's essentially this. Control C that. Control V. This will be the selection. And essentially if it's a standing, we want to, on the character, we want to uncrouch. So state standing, aiming or no aiming. And if it's crouching, we want to crouch. So if we go back to our first person, and now everything is being controlled, we've disconnected all of these, we've connected the input actions here, we send a state tree event, which then transitions, and now we can see if it works. So we play the game. So we've got our normal state there. If I arm, he becomes armed. If I crouch, he's crouched, aiming. Press X to unarm him. Uncrouch. Crouch. Aiming. And there. So that seems to work okay. So we're now driving our animations using the state tree. So as I said, in the next videos, if there's interest, we can try and turn this into a enemy state tree, where we can have the enemy with an AI controller transition depending on AI perception or on EQS queries and so on. We could maybe even add a shooting mechanic to this character, as we do have a weapon attached, and maybe retarget some of these animations to the UE5 mannequin so that our player character and our enemy NPCs look different. So that's something that we can look at to do in subsequent tutorials. So do subscribe and comment if that's something you're interested in.